Welcome to CS420 Lecture 3, and we're going to start off by talking about types. Now types are integers, string, booleans, etc. And you've hopefully dealt with these since you first started to learn how to program, so you've probably heard the word type before. Now users can create their own types, like in object-oriented programming. When you create a class, you are inventing a new type. Now there's two things with type checking. Is our type checking dynamic or static? And another thing is our type checking weak or is it strong? Now dynamic versus static has to deals with when the type checking happens. If the type checking happens as we're running our code, then it's considered dynamic. If it happens as we're compiling our code, then it's considered static. Now, you remember in Java, hopefully, when at first you had to do Java C to compile your code, and that is when the type checking happens. Java does its type checking at compile time. So, and in fact, as you're typing your code into your IDE, if the IDE is smart enough, it can point out your type errors. It could say, hey, you're passing in a string and I'm expecting an integer. And you'd see a red underline right when you're typing, and that's static type checking. Now, dynamic type checking is more like Python. So Python, it does it. Your program can be running as it's running. Even though there's a type error in the future, you typed your program and you put an error, you like added a string and a integer together, which Python doesn't allow. Your program will run until the moment that you try to add a string and a number, and then it crashes right then. So you'll see the output and print statements run before your program crashes and notifies you of the type error. Now, versus Java, you can't even compile your code and to even get it to run if you have a type error. In Python, you can run your program and it will, if you never actually execute your type error, let's say you put it in a function you never call, then your program will run, even though there's a inconsistency where the types don't match up. Now, the weak versus strong is how much help the language gives you in getting your types correct. And again, Java is a very strict in its type checking. You can't add a string and a number together. It won't let that happen. Versus Python is more weak. It doesn't give you help. In fact, because you don't declare your types, a lot of times it's really hidden and you don't really know what the type is as you're doing it. Weak is also more relaxed in its type checking. If it finds a way to do the operation on the types, even though they might not be completely correct, it'll let it happen. Versus strong type checking is very strict. Now this is kind of more of a continuum. You can have languages that kind of line up in the middle. They're somewhat relaxed on some stuff and strong on other stuff. But just as an example, Python is really considered a weak and a dynamic type checked language versus Java that's a static and strong type checked language. Now, it isn't always the case that strong type checking is also static type checking. You can have a strongly type checked language that does it at runtime. You can also have a weakly type checked language that does its type checking at compile time. Now, one thing with compile time, obviously Python isn't compiled, it's interpreted, but it's kind of more at parse time. As we're reading through the code and figuring out what it means, that's parse time. And then runtime is as we execute the code. Now we're going to talk about a new type in Racket, and that is pairs. There are basically three operations to a pair. Cons, which creates a new pair. Char gets the first item out of the pair, and Cadr gets the second item out of the pair. Now, pairs are really easy. There's only 3 operations, but when you're in the midst of things, sometimes it gets really confusing. And my recommendation is go back to the beginning and make sure you remember these 3 definitions. Cons creates a pair, Car gets the first item out, Cadr gets the second item out. And these names, they have a history in computer architecture. When they were creating a computer, they had an address register and a data register. So in order to implement pairs, they put one item in the address register and another item in the data register. Now that's why it's called car, A for address, and D for the data. That's just a little history of how these names came about. Now I'll show you to create a pair. We just do cons and we put the 2 values we want after it. So once again, it follows the same format that Racket always does. An open parenthesis means we're going to call a function. We're going to call cons. And then 10, that's the first parameter, and 20 is the second parameter. So 10 becomes the first item and 20 becomes the second item in the pair. And when you run that, you get this printed out where 10 and then a period separates the 2 items in the pair. So we can do that cons 3, 7 as well. Now we can save these for use later on, so we can define A to be cons 10, 20. And we can define B to be cons 3, 7. And we'll run that. And we can print out A and B. And what we can do now is we can cons A and B together. Now this takes the value A, right, and it looks it up and it finds this pair. And it takes the value B and it finds that pair. And it cons them together. And then we get something that looks like this. Now, as you can see, our little dot notation thing is starting to get a little messy. That's because the printing it out is optimized for something called lists, which we're going to talk about next. So because it's like that, our pairs kind of break down. We really should see another parenthesis right here with a period in the middle, and that's missing. So it makes it a little bit confusing. That means is that you're going to have to work on your own to figure out exactly what this looks like. And we use box and pointer diagrams for that. So this is from the lecture note. When notes and we cons 10 and 20 together, you just make a box with a line in the middle, and you put the first item in the first box and the second item in the second box. So this is what cons 10, 20 looks like. And cons 3, 7 or B looks like this box. We got 3 and 7. And notice the name points to the box. Now when we cons both of them together, I'm going to call that C. It creates a new box like this, and we have 10 and 20 in a box over here, and we have 3 and 7 over here. So if we get the car of C, we're going to get 10 and 20 out. If we get the Cadr of C, we're going to get 3 and 7. Now, I'm going to show you that in code next, but you know, car, if we get car of B, we'll get 3, and Cadr of B, we'll get 7. So first we'll just define C to be the cons of A and B together. I already did that down here, but now I'm going to define it as a name up at the top. So when we print out C, we get that. Now if we do a car of A, notice we get the 10 out. Cadr of A, we get the 20 out. Likewise with B. Car of B, we get the 3 out. Cadr of B, we get the 7 out. Now, if I get the car of A, notice I have 10 there. I meant to do the car of C. And notice C, the car, the first item is just what A was. So that's a pair with 10 and 20 in it. And the Cadr of C is the 3 and 7. Now, what if I want to get this 3 out starting at C? So let's pretend we can't reference B to get it out. We have to start at C. Well, we would take the Cadr of C first, and that would give us the B part, the 3, 7, and then we would take the car of the result of that to get the 3 out. So if we look at this diagram right here, here's C, and if you notice first I took the Cadr of C, which gives us this box right here, and then I take the car of that and I get the 3 out. So we can see Cadr is the second one, follow it to here, car is the first one, and we get it there. Now the only tricky thing might be this prefix notation. If you notice right here, the Cadr, this is what we do first, but that's the second thing in our code. So because of prefix notation, remember we start with the inside and we work our way outside. So this Cadr really happens first, and then the car happens. Now it's very common to pair these all together, so there is a function called Cadr, which does the exact same thing as this. All we do is we take these in the order they're listed if we were to run it, and we can just combine them together like that. So there even is a function like this. And so what this means, and it won't work because we won't have that big of a list of pairs, but what it will do is it will take the Cadr first, then it will take a car, then another car, then a Cadr, and then a Cadr again, and then a car. All right, next we're going to talk about lists. And lists have a very simple definition if you think recursion is simple. It is a recursive definition, but pretty simple. A list is either an empty list or the Cadr is a list. So we have the empty list. Yes, that's a list. If we add something in here, now the Cadr is an empty list, which is a list, and here's our element in the list. So this entire box is a list. Now we can add something else onto the front of that. And this entire thing right here is now a list. Why? Because this Cadr is an empty list, and this Cadr is a list. As long as all the Cadrs are a list, then we have what is considered a list. So the best way to see these in box and pointer diagrams is the element goes in the first spot, so 4, 5, 6, and arrows in the second spot, and then we could do the empty list right here, but we usually just put a slash in there, and anything that looks like that is a list. Now it could be a little confusing because we could replace that with some other pair like our A up above that we talked about before, but this is not a list, but this thing is a list. It has 3 elements, 4, a pair with 10 and 20 in it, and 6. So lists are things that are made out of pairs where the first thing, the car of the pair is an element, the first item, and the second item is another list, or the Cadr is another list. Now we could make a list with cons, so we can cons 6 and the empty list. So to type in the empty list, we just do an apostrophe in front of it. So right there we have a list with 6 in it. Well, what we can do is we can cons 4 onto the cons of 5 onto the cons of 6 and an empty list. So to type in the empty list, just do an apostrophe and the closing parentheses right there. So this is one way to make a list with 4, 5, and 6 in it. And we can see right here, now our pretty printing comes into effect, and we can see that lists print out really nice. We just have an open parenthesis with the elements inside. So that's why our previous printing didn't work really well, because they optimize it to print list out really well. And mostly we'll use lists. We won't be using pairs as much. Now another way to create a list is we could just go list 4, 5, 6. and that'll create a list. And a third way to create a list is to use an apostrophe and go 4, 5, 6. And that is a third way to create a list. And all of them produce the exact same thing. The box and pointer diagram underneath them is the exact same thing. Now, one thing to mention with this apostrophe, whenever we do an apostrophe, what it's doing is kind of like put in quote marks. It's like take this thing literally. Don't look up variables. So if I do A and B right here in a list like this, notice the apostrophe in front of it. I just get a list with A and B back. Versus doing list A, B. In this case, A right here is this guy up here, and B is this guy right here, so we made a list with two of them in here. Notice here's the first one and the second element of a list. So we can do the same thing as this first option by doing list apostrophe A, list apostrophe B. Because now, instead of these being variable names, they are symbols. And when we put an apostrophe to make a list, we turn everything inside of it as a symbol. So we can even make a list with operations like cons, Cadr, and car. And instead of these being functions, they turn into symbols. And this could be a little confusing because cons is a function that you call. But now I made a symbol called cons, which might be a little confusing. We probably wouldn't do that. But we can with this apostrophe by turning things into symbols. So read through the lecture notes on that a little bit more. Make sure you kind of understand what that apostrophe is really doing. We can even put lists inside a list like 5. And then the second element is another list with 5 and 6 in it. And then 7. So this really is a list with 3 elements in it. 1, 2, 3. So it's just the second element happens to be another list. So these are some useful operators you can do on lists. We won't spend the time doing each and every one. And I already showed you list is makes a list. I've already showed you cons. If we do cons, an element, and another list, that adds a new item onto the beginning of a list. Now, you'll have to figure out later how to add something to the end of the list, but there isn't an operator that does it. Of course, car and Cadr you've learned about. Append will combine 2 lists together. So if you have 2 lists and you want to combine them into a single list, then you'd want to use append. Now, reverse. Length is the length of the list. Remember, this is a good thing to test to see if something is inside of a list. Now this I'll probably spend more time talking about in the future. This is a very key thing in functional programming languages. There's an operation called map reduce, and the map is the first part of that. So we'll spend more time on that in the future. Now finally, I won't do these examples for you, but you should look at these vectors and read through them and try them out on your own. And there are 2 comparisons just to end up this lecture. Make sure you read these. One of them compares, this right here does a deep comparison, whereas this just makes sure that these 2 things are pointing at the same element, or a shallow comparison. So there are a slight difference between equal and EQ.